For this first test, I have removed the rotor of the synchro or resolver here for the outer gimbal. Okay, so I have placed this winding here, and I have supplied this rotor with an AC voltage of 10 volts RMS, approximately 400 Hz. And I have connected an oscilloscope between slip rings 3 and 4. Okay, and we can see that we have effectively an AC voltage which depends on the position of the outer gimbal, the relative position. Okay, you can see the phase reversal. For the second test, I have connected the reference winding of the inner synchro, okay, to an AC voltage. The reference winding of the inner synchro is connected also to the reference winding of the outer synchro, which is this winding here. So we can see something very strange, is that the stator of the inner gimbal is actually in parallel to the stator of the outer gimbal. The oscilloscope is connected here between pin 4 here and pin 9, okay, which is also the stator of the outer gimbal. And we can see that we have effectively a signal which depends on the position of the inner gimbal. Okay, so this is weird. So we have effectively the complete pinout of the slip ring contact. We have between slip ring contacts 1, 2, and 7 here 2 windings for the torque motor of the inner gimbal. So this permits to modify the orientation of the outer gimbal, okay, because of the precession of the gyro. We have the 2 synchros between pins 4, 8, and 9. The 2 synchros are in parallel. And there is another winding between pin 3 and 9 here. Okay, and we have between slip ring contacts 5 and 6 the reference winding for the torquer of the inner gimbal, and the windings of the AC motor connected between slip ring contacts 10, 11, and 12. So in conclusion, both synchros are in parallel, the stators and the rotors. So of course this is a strange arrangement, so the only possibility is that the system will search for 0 on both synchro. If there is an error on one axis, there will be a change of the current on the torque motor in order to retrieve the 0 position. Okay, so we can have a look also on the wiring. So we have on the bottom here, these 3 contacts correspond actually to the stator of the synchros. So we can see we have 2 wires here, 2 wires and 3 wires. So one wire is connected to the slip ring contact here. The second wire is connected to the stator of the outer synchro, which is this coil here. Okay, and we can see the yellow here, so we have 3 wires. One additional wire is connected to another winding. This is the schematic here. We have the stator of the synchro, and there is another coil here between pins 9 and 3. So I don't know exactly the purpose of this one. So this corresponds to the additional wire. Okay, so we have 3 wires on that pin, one for the inner synchro, one for the outer synchro, and another one for this winding here. Okay, so we can notice also another interesting thing is that we don't have on that gyro the gravity sensors we usually find in avionic gyros. We can see that this capacitor, which is connected between these 2 windings of the AC motor, is quite small, 27 nanofarads. from my experience, this capacitor should be much higher. Generally, it is between 200 and 400 nanofarads. Okay, so I have disconnected also the second gyro, and there is actually another capacitor which is in parallel, and the value is 270 nanofarads. So therefore, I have added a capacitor of 270 nanofarads, which is on the capacitor decade box here. Okay, so the 27 nanofarads is not connected, so this capacitor is actually 170 nanofarads, and between terminals A and B there is an AC voltage of 115 volts. Okay, so let's turn on the power supply. Okay, so you can hear the gyro spinning, but it is very noisy at full speed.